Video solutions on function work. Okay, so it says complete the sentence. The input variable is called the, that's an easy one, the x variable. The output variable is called the y variable. The reason it's the input is because you must start with that to get the output. Okay? Tell whether the pairing is a function. We know we have two basic kind of rules, one for a table or data and one for a graph. With the tables, we say that every x input needs a distinct y output. In other words, you can have two of the same x inputs give you different y outputs. They would have to give you the same one. So if you look at number 3, our inputs are 1, 3, 5, and 7. So that's going to be okay. So this is a function. Okay, number 4. Here again we have all different inputs, but they give us the same output. So from our working class, we know that if we were to graph these, it would actually give us a horizontal line, which we know is a function. Different x inputs can give you the same y output. We know that from the function, for example, y equals x squared. If I substitute 1 in for x, 1 times 1 is 1. But if I substitute negative 1 for x, negative 1 times negative 1 is also 1. Okay, number 5. We notice that we have the same x input here, but it gives us two different y outputs. So we know that would make a function. Somewhere on the graph of this, there would be a vertical line. Okay. Make a table for the function. Identify the range of the function. Okay. Oh, my thing's going a little screwy. All right, so let's just do a quick table. I'll make a t-table like this. Okay. We know that this is our input. That's our output. So our domain is our set of inputs. And then we just simply substitute those x's into our equation. So 4 times 1 is 4, minus 2 is 2. 4 times 2 is 8, minus 2 is 6. And so you can see from our pattern right here, we're adding 4, which of course matches our slope. So we can just continue that pattern down here. Okay? We know that our y is our range. Okay, so let's make another function table. Let's go to number 8. I'm going to skip a little bit. Okay, we have our domain right there and our range. So our domain is 6, 7, 8, 9. So we substitute. 1/2 of 6 is 3. 3 plus 2 is 5. Now, right away, we don't have to even do any more of the substitution if we recognize that the slope is 1/2, and that's going to be our pattern here. So we know going from here to here is simply adding 1/2. So that's going to be 5.5. This is then going to be 6, and that's going to be 6.5. So I'm using the equation to help me figure out my y coordinates. We know our y coordinates, again, are the range. Okay, next page. I skipped number 8. Write a rule for the function. Well, we know that our rules are going to be in slope-intercept form. Y equals mx plus b. M is our slope. B is our y-intercept. So we know our slope is the difference of the y's over the difference of the x's. So in this case, our pattern of our y's is adding 5. Our pattern of our x is adding 1. 5 over 1 is 5. So we know it's going to be y equals 5x. Now, plus, we know that we have to get back where x is 0. So if I'm adding 5 going this direction, it means I subtract 5 going back. So 5 minus 5 is 0. So our y-intercept is 0. So the correct way to write this would be just to write it y equals 5x. Number 10. Okay, so again, we have our slope would be our difference of our y's, which is adding 1, over the difference of our x's, which is adding 1. So our slope is 1. So we know we're going to get y equals 1x, or just x, plus, okay, I'm adding 1 going this direction, but I got to get all the way back here to where x is 0. Okay? So like in class, we can just redo the graph, or we can do it up here. So I'm going to actually go 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So if I'm adding 1 going to the right, I have to subtract 1 going to the left. So that means 9 would be 2, 8 would be 1, 7 would be 0, 6 would be negative 1, 5 would be negative 2, 4 would be negative 3, 3 would be negative 4, 2 would be negative 5, 1 would be negative 6, and 0 then would be negative 7. So I can either write it like that, or I can do y equals x minus 7 if you'd rather do that. Now let's just substitute to make sure we did it right. Let's take one of the ones that we already have. Let's substitute 12. So if I put 12 into this equation, y equals 12 minus 7, so y equals 5, and that's what we got, so we proved it. Okay, let's go ahead, and we're going to skip 11, 12, and 13. We'll do those in class. Okay, I got this new software, must need to do something with it. Okay, and then go to the next page. All right, number 14. Got some funky things going on here. Okay, well, I guess it's just a new page. Whoops. Okay, graph the ordered pairs. I'm only going to do a few. We just need to remember that the first coordinate is x, second coordinate is y. That's all they want you to do. Over 3, up 4, over 4, up 7. So they're counting by 2's up here. Over 5, up 10, etc. Okay, so you can do number 2, no problem. All right, number 3 says complete the input-output table. All right, just like 7th grade, you just substitute. So I have x is 0, so the input is 0, so 3 times 0 is 0, 0 plus 2 is 2. Okay, substitute 1 in there. 3 times 1 is 3, 3 plus 2 is 5. And since we have a pattern going this direction of adding 1s, then I can simply continue my pattern here, which looks like it's adding 3. And we know that from our slope right there, don't we? So that's got to be 8, and that has to be 11. Okay, you can do number 4. Okay, graph the function. Well, we learned in class that we can either use the equation in slope-intercept form, or we can make a table. So let's use the equation, because obviously that's what you're going to need to do in algebra. This is not in slope-intercept form. So if we go ahead and do our same change switch, we know that 6 plus x would also be negative x plus 6. That is in slope-intercept form. Our slope is negative 1, and our y-intercept is 6. So we know we're going to be right up here. And then negative 1 means up 1 and over 1 to the left, but since I'm out of room, I'm going to go down 1 and over the other direction. We know slope is negative, so that's a negative slope. We know whenever we have a slope of 1, it's a 45-degree angle. Okay, so then I just kind of line them up, draw my line, and put some arrows. Okay, number 6. Y equals 1/3 x. That is in slope-intercept form. It just doesn't have a y-intercept. Well, technically it does, but it's at the origin, isn't it? And then I can use my rise over run. So 1/3 means up 1 and over 3. Now notice we're counting by 3, so that's right there. Up 1 and over 3. Up 1 and over 3. Okay, then go ahead and connect them. So even though that looks like a 45-degree angle, remember they're counting differently on our x-axis, so it's not really. Okay? Okay, 7, you can do 8. Well, 8 has a decimal. I don't really like that. We want to use fractions, so I'm going to change that. The way to change a decimal to a fraction is read it without the decimal, so that's 12, and then what's the last place? That would be tenths. So I'm going to rewrite this to y equals 12 tenths x. And then I'm going to simplify. So it looks like 2 goes into both, so y equals 6/5 x. Okay, it doesn't have a y-intercept, so we know it's at the origin. So now I'm going to go up 6/5. We're counting by ones. So I don't have any more room, so I can connect those two. I'm pretty sure I did it right. And there we go. Easy enough. Okay, next page. Write a rule for the function represented by the graph. So they want you to write the equation. Identify the domain and range. Well, we can do this two ways. One, we can make a function table using the coordinates, and from that make our equation, and then we'll know our domain and range. Or I can use my graph and do the same thing. So we know in this one it crosses the y-axis at 6, so that's going to be our y-intercept. And it looks like it goes up 1 and then over 1. Up 1 and over 1. So we know our slope is 1. So y equals 1x or x and then plus 6. Okay, let's try that on the next one. So I'm going to draw my graph, but watch what happens on this one now. Okay, so if I do that, look what happens when I take and extend this through those lines. It doesn't look like it crosses at a point on our y-axis that I can determine. I'm not sure what that is. So this time I'm going to do a function table and show you how this works. Okay, here's our x input, here's our y, and I'm going to use these coordinates. So I know that I'm going over 1, and then I'm going up to 3. I'm going over 2, and up to, that must be, looks like 7. Going over 3, and that must be 11. Then I'm going over 4 and up to 15. So to double check that these are right, look at our pattern. Is it the same each time? Sure, it's adding 4. Okay, so now let's go ahead and write our equation. We know that we take our slope, which is the difference of our x's, over the difference of our y's. So our slope is going to be 4. So y equals 4x. Now we need our y coordinate to be 0. So just like earlier in the homework, if I'm adding 4 going this way, I'm going to subtract 4 going the other way. So if I subtract 4 from 3, I'm going to get -1. So that's going to be our y-intercept. Now I couldn't see that down here exactly, so it's better to do the actual table. So you can do that on number 11. Okay. And I think what it will do is I'll let you go and work on 12 through 14, and we'll go over these in class as well. That way I can get this video done. All right. Good luck.